Okay, I think we should start now. Can you hear me? Is it fine? Is the audio fine? Okay, sounds good. So good evening. Welcome everyone to attend the class Global Open Course, the Global Climate Change and the Response from the Perspective of Carbon Neutrality. So my name is Jing Cao. I'm an associate professor from School of Economics and Management at Tsinghua University. So this week, I will focus on the economics of climate change. Okay, so let's start. First, let's see what is the current problem right now. So why is the climate change so pressing? The graph that I show here is I cite from Climate Action Tracker 2021. So this is a graph that based on the most recent simulation and projections. So, so we can see that let's assume that our benchmark is pre-industrial average. If we do not do anything, so based on the new data, in 2021, we are already increased 1.2 degree warming from pre-industrial average. So we're here. So our goal, you can see that we already increased by 1.2 degree. Our 1.5 degree, we only have 0.3 degree to go. So let's see what kind of the scenarios, policies we have, and how does that result in how many temperature increase. So let's base on the current policies. So that is highlighted in the color of blue. So based on the real world actions of the current policies, the mean temperature will increase by 2.7 degrees above the pre-industrial average, with a lower bound 2 degree and upper bound 3.6 degree. Okay, so let's try to make our policy, for instance, assume that we have achieved 2030 NDC targets. So let's assume that we have a full implementation of the 2030 NDC targets. Wait a second. You cannot see the latest PPT. That's so weird. Okay, so well, let me. It's weird. Let me try to. Okay, so our. I'll try again. Can you see the PPT now? Is it working? Okay. Okay, so let me restart on this one. Okay, so here's this temperature bar here. So the 0 degree is a pre-industrial average. And we are already having a 1.2 degree in 2021. If we implement all the current policies, then our average temperature will increase by 2.7 degree, with a bound between 2 degree to 3.6 degree. If we have a full implementation of 2030 NDC targets, then we'll improve a little bit. So roughly about 0.3 degree. So we were basically also in this orange region. So we'll increase the global mean temperature by 2.4 degree with a bound 1.9 degree to 3 degree. Okay, so if we have a full implementation of the submitted and binding long-term targets plus 2030 NDC targets, then the global mean temperature will increase by 2.1 degree. The most optimistic scenario, if we have a full implementation of all announced targets, including the recent net zero targets, then our temperature will still increase by 1.8 degree. So you can see that we still have a very long way to go. Even with all the projected policies, we very likely exceeding the 1.5, the Paris Agreement's goal. So that is indeed a global issue, very, very severe global issue right now. Okay, so since the topic right now, we're focusing on the economics. So I want to start very beginning, why we have this issue. How can we use the economic theory to understand climate change? So we'll have to talk about externality, free rider, and property rights. So let me start with these basic principles. In general, if we have a competitive market, the market should be pretty good at allocating goods and services. It's like invisible hands. So in the market, people have a willingness to pay to purchase the goods. And the producer will also utilize the capital and labor to produce it. And eventually, supply equals demand. Then we will have an equilibrium price and equilibrium quantity. At this equilibrium, consumers are maximizing the consumer surplus and producers maximize the producer surplus. However, in a lot of the environmental questions, we will have certain problems. For instance, most of the environmental issues is related with externality. So externality exists whenever the welfare of an agent depends not only on his or her own activities, but on the activities under the control of some other agents as well. In particular, to the climate change externality, the greenhouse gas emitter do not need to pay for the cost of greenhouse gases. So that is a most basic roots to the climate change problems. One likely cause of externality is lack of property rights. For instance, if we talk about the pollution, the air pollution, so if the receiver owned the air, the emitter would have to pay the receiver to use the air to emit greenhouse gases. Or if the emitter owned the air, the receiver might pay the emitter not to emit its greenhouse gases into the air. So the lack of property right is a major source of climate change problem. When we talk about property rights, we're actually referring to a bundle of entitlements that defines the owner's rights, privileges, and limitations on the use of a resource or environmental assets. The property rights can be held by different individuals, corporations, or the government, all in common, or at the extreme by no one, like the air. So what might be the how can we solve these externality issues? So how can we alleviating the externality? So there are a lot of policies that we can think about. For instance, we could put a tax on the emissions. We could put a restriction or a cap on the amount of emissions. Or we can have the emitter and the receiver to make a negotiation, or we can have a joint ownership of the two agents. Okay, So in order to achieve carbon neutral or net zero, let me talk about the economic theory and what are the instruments, what are the toolbox that we can apply. So to look for the tools, just keep in mind, we have three main questions to answer. So the first question is actually related to economic efficiency, especially the efficiencies of policy instruments. So how much carbon emission is optimal? Or let's say how much emission control is optimal. So this is basically all these optimality issues. So we are going to look for, this one is the efficiency problem. So we wanted to look for what is the optimal policy. And the second, what is the least cost way of reducing carbon emissions if we have already set our target? For instance, if we set our NDC target, or if we set in 2060, China wants to go carbon neutral, what is the least cost way? Okay, so the first question, we have to solve the optimal problem by comparing cost and benefits. But the second question, actually, we only need cost information. So to answer the second question is relatively easy than answering the first question. So we wanted to find out, in order to reach the environmental target, what is the most cost-effective way? Okay, finally, the question we wanted to answer is, how should the control of emissions be assigned to different sources? So we wanted to know, what is the incidence of the policies? What is the distributional effects? In order to have a deep decarbonization, so basically we have all kinds of policy instruments, but most of these policy instruments all basically fall in the following four categories. So we could have a standard or command control, or we could have a technology mandates, we could have an emission standards, or we can have a price-based instrument. For instance, we could have a carbon tax. We can also have a quantity-based instruments, like we could have an emission trading policy like cap and trade. Finally, we could set up a voluntary market. So if companies, they have strong corporate social responsibility, the company wants to achieve their own carbon neutral target, but without an environmental regulation, the company can set their own company target. So that is what we call voluntarism. Okay, so let's start from the first policies. So if we have the full information, if we know each firm, what is the abatement cost, how much cost will incur in terms of the reductions of the emissions, then what we can do is a very simple way. We can just set an efficient standard for each firm. But the problem is, in reality, the regulator does not know the shape of each firm's marginal abatement cost curve. So in theory, standards are reasonably good at controlling emissions if they have the information. However, in order to make things work, they often do so at a very high price. The second approach is carbon tax. So how else would we get firms to reduce their output of pollutants without setting up standards? We can impose a tax on carbon emissions. Instead of telling the firms what to do, what technologies, what abatement they can do, we can just use one number, one carbon tax, to raise the price on carbon to impose more burdens on fossil fuel users. So we can use these kind of price-based incentives to control emissions. But then the question is, what tax rates might we use? for the emission charges or carbon tax. So let's take a look at these graphs. This is a very simple graph. Let's just simplify that. Our world, we only have two firms. So we have firm number 1 and firm number 2. These firms are very different. They're both emitting emissions, but they have different technologies. They might produce in different industries. So anyway, because of this heterogeneity in terms of marginal control cost, so which I indicate here, so you might see that the firm 1 has a relatively flatter marginal control cost curve, but firm 2 has a relatively steeper marginal control cost curve. So we could set a tax rate exactly at the level of, the two curves intersect with each other. Okay, so each firm was actually comparing their own marginal control cost with these stated tax rates. So think about that. So if you can reduce emission by yourself at a lower price, then the rational firm will choose to reduce emission by itself. But the more you reduce the emission, the higher the marginal control cost. Once the marginal control cost reach the stated government carbon tax rate, which means that if you want to reduce 1 more unit, then your marginal control cost will be higher than the given tax rate. So the rational firms will choose not to abate any further. So they want to just pay government the carbon tax. Okay, so every firm, so this is only an example of 2 firms, but you can see no matter how many firms here, even for N firms, everybody will comparing their marginal control cost. They will all, as long as it's under the tax rates, they will abate emission by itself. But once it's reached tax rates, because the marginal control cost will become higher, then they will choose to set the last unit marginal control cost equal to the tax rates. So when every firm think about this way, in the end, all firms have the same marginal control cost. So this is also the condition for cost effectiveness. So in order to achieve cost effectiveness, which means in order to reach the environmental carbon abatement targets, the best way is to make all the firms to have the same marginal abatement cost. Then that is when you have no choices to make it reduce further costs. So for each individual firms, the cost actually can be divided into 2 categories. One is the total cost of control. So that was a part 1 marginal control cost below the tax rates. And then the other burden is they have to pay for the amount of pollutions emitted to the atmosphere, which they do not abate by themselves. So basically the total cost include the total abatement cost plus the tax payments. Okay, so that was a theory of the carbon tax. But how could we actually set the correct tax rates, given that we may not know the exact shape of the firm's marginal control cost functions? So since we do not know the shape of all the marginal control cost functions, so the only way to set the correct emission charge rate would be to use an iterative procedure. The control authority would have to try out 1 rate, and they can adjust it over time until the optimal amount of abatement is achieved. Okay, so let's see how a carbon tax rate would react to the changes in external circumstances. So we can just look at 3 conditions changes here. We can look at what about inflation. In a lot of developing countries, also in developed countries, sometimes they have higher inflation. What if we have a lot of we have a lot of new firms entering the market. What about we have technical progresses in terms of abatement technologies? So we can do this one by one. So what if we have inflation? So the inflation means that, okay, so even if our nominal tax rate doesn't change, everything else become more expensive. So the capital become more expensive, the labor become more expensive. So you can see all these factors, prices were increased. Therefore, the marginal control cost relatively to the nominal tax rates, they will become higher. So MCCT equals to 0 was shifted to MCCT equals to 1. So you can see that comparing the two outcomes, before the inflation, the firm will reduce pollution at QT equals to 0. But after this policy, after this inflation, under the current tax rate, you can see that this new MCC curve cut with the tax rates level, and then the outcome is smaller. So the quantity firms controlled are smaller. This is also means when we have an inflation, the tax rates, if it's unadjusted, the nominal tax rates unchanged, then the effective tax rate is weaker. So the pollution controlled is also smaller. Therefore, if we have an entry of the new firms, so suppose that all the new firms, they have the same emission profile, then for each individual firm, there's no change. But if we add up all the emissions, then the total industry-wide emissions will go up. Of course, the tax revenue will also go up. So if you have a growing economy, you have all these new entering firms, so with the carbon tax, it's very unlikely that we will have a reduction on total emissions, because the existing firms are reducing emissions, but and meanwhile there will be more and more entering firms, so the total emissions might increase. What about we have a technology progress? Okay, so the technology progress means that if you wanted to reduce 1 ton of CO2, you use less capital and less labor input. So the MCC curve shift to the right. Okay, so you can see the shaded area here. These will be the cost saved by the firm, which include the cost saving in terms of pollution control and cost saving in terms of less pollution tax paid to the government. Actually, this is a very good thing about carbon tax, because this is very unlikely, like the case that the mandate policy, that especially technology mandates, the government ordered the firms to pick abatement technologies. In this example, as long as you have these price instruments there, the firm will always want to get more and more cost savings. So they have this motivation, they want to push forward the MCC always to the right. So you can see these dynamic incentives on the technology change. Okay, so to sum up, the inflation entry of the new firms, these will make the tax instruments weaker. But given the incentive for the technology changes and incentives on the dynamic cost savings, it makes carbon tax a very good instrument. Okay, so let's comparing the cons and pros of carbon tax. The carbon tax requires less information than the command control approach. The total cost of control likely to be less than the command control. The good thing about the carbon tax, it raises revenue for the government. You can use the revenue for a lot of things. You can use it to stimulate for the technologies or renewables. And also, as long as you put a price signal there, it has this dynamic building incentive for the firms to adopt more advanced technologies. What about the disadvantages? The disadvantages we have shown already. If a firm has a very higher growth rate and the inflation is very high, without this frequent adjustment on the tax rates, amount of pollution control decline with inflation. If the economy has more and more new firms to enter the market, the total emission may likely to increase. In order to have an optimal amount of pollution control, it also requires government has a relatively fair amount of information so they know where to set the tax rates. Sometimes it's difficult to plan if the control authority changes the emission charge rate. And also monitoring emissions might be expensive and difficult. Okay, so the third instrument in the toolbox we have is emission trading, especially for carbon, like cap-and trade. Actually, tradable permits have been used for a lot of circumstances, like the SO2 reduction, electric gasoline phase out, the EU carbon trading, the EU ETS. In China, we had a pilot carbon emissions, and we have China's national carbon emissions trading in the electricity sector. Okay, so let's take a look at the same graph that we just showed. So suppose that we do not have a tax rates, but we have initial allocation of permits. Let's just assume that the two firms get equal amount of permits. So you can see that at the initial allocation, the firm 2 has relatively much higher marginal control cost than the firm 1. So basically the two firms, if they have a market, they can trade with each other. For firm 2, it is too expensive to abate the emissions by itself. For firm 1, it actually has a relatively comparative advantage to sell these emission analysis. So one wanted to buy and the other wanted to sell. So you can see that as long as the price is between the gap of MCC2 and MCC1, then they always find a deal to make both better off. So the process can continue until they're both at the intersection, which is go back to the same outcome when we have a carbon tax. So cap-and trade requires even less information than an emission charge system and maybe much less than a command control system. The total cost of control are likely to be lower, and the total amount of pollution is not affected by inflation. So this is very different from the carbon tax. The total amount of pollution is not affected by entry of the new firm, because if you have a cap-and trade, then you already cap the total emissions. The disadvantage is if your set analysis at the downstream, as each individual firm, the monitoring from level emissions usually will be very expensive. So in China, we had the third-party verification, and this is not that easy. If we do not have an auction-based trading system, then cap-and trade or any other emission trading system, they will not raise revenue for the government. And in particular, if in the emission market, there are only a small number of firms, it's very likely that firms might engage in imperfectly competitive behavior. For instance, if they have a large sellers, they might hold on to the permits so they can drive up the price, so that we might have a monopoly system. And then they might have some kind of the distortions there. Okay, so it comes to these policy issues. What instruments should regulators choose in reducing emissions? Should they issue tradable pollution permits to the firms, thereby picking a quantity? Or should they tax polluters, thereby picking a price? So there is a very famous paper by Martin Weissman. So he has a paper published on Review of Economic Studies. So the title is Prices versus Quantities. Okay, so this paper provides a very, very solid and beautiful system theory to explain and apply that to the instrument choices on emission reductions. So let's see what the story is. So Professor Martin Weissman, he highlights that, especially for climate change, we have a bunch of uncertainty here. So basically, people really doesn't know what is the future marginal control cost. Okay, so he would think about the two situations. This one situation is the marginal damage curve might be steeper, and the marginal control cost might be relatively flat. And then the other situation is vice versa. Marginal damage cost curve is flatter, and the marginal control cost is relatively steeper. Okay, we can also have uncertainty about marginal damage cost curve. So the idea is if people does not know the marginal control cost, which means we do not know what might be the future technology and what might be the cost associated with it. For instance, like right now we have these DAC technologies. We can directly capture the carbon emission from the atmosphere. But the thing is we do not know, we might estimate, okay, it might roughly $200 per ton, but we don't really know that in 20 years, in 30 years, we do not know with the learning effects how much cost will incur in the future. We might also do not know what might be the marginal damage cost if the temperature raises by 1 degree, 2 degrees, 3 degrees. So we can only have kind of like a kind of guess on the likely range of marginal damage cost. Okay, so according to Weissman's theory, okay, so the first scenario is maybe the marginal damage cost is relatively steeper than the marginal cost curve, marginal control cost. So if the marginal control cost is relatively flatter, okay, so you can think about the two choices. If we choose the price-based instrument, so firms will stop reducing emissions until the marginal control cost reach the tax-free level. So this right shaded area will be lost from using taxes. If the government choose using the quantity-based treatable permit system, so that will be the QP here, indicated here. Okay, then you can see that there will be a smaller shaded area, a triangle here, that will be the loss from using permits. Okay, so now this, you can see very clearly that using tax in this situation will incur more cost, more distortions than using permits. Okay, so if the marginal damage cost is relatively steeper than the marginal control cost, permits should be favored. Vice versa. If the marginal damage cost is relatively flatter and marginal control cost is relatively steeper, then the results will be totally opposite. So the loss from using tax is relatively smaller than the loss from using permits. What about we have an unexternality? We have an uncertainty about marginal damage cost. Okay, so if people doesn't really know, or we do not sure what will happen if the temperature, global mean temperature increases by 2 or 3 degrees. Okay, let's suppose that the solid line is real marginal damage cost, but this dotted line will be the expected marginal damage cost. Okay, then you can see that no matter you use the tax instruments or treatable permits, basically the losses from using the taxes or the loss from using the permits will be identical. Okay, so only in these situations when we have uncertainty on marginal damage cost, it doesn't really matter which instrument to use. Okay, so that would be a very simple example about, you can basically comparing, the relative slope of the marginal damage curve, cost curve, and marginal control cost curve. So some people actually argue that maybe in the near future, the marginal control cost to reduce carbon emissions will be relatively higher cost. But meanwhile, the damages is basically in very distant future. It's not so alarming. In that case, maybe we should use the tax instruments because the loss of using taxes are relatively steeper, smaller. Maybe 50 years later, the climate change does impose significant marginal damages. So maybe the marginal damage curve shift more steeper, but with the technology improvement and when we have a lot of these technology improvements, maybe the marginal control cost is relatively flatter. So maybe 50 years later, maybe using the traceable permits is more cost effective. So there will be an example here if we adopt Martin Weissman's price versus quantity framework. There actually are, in addition to this paper, there are additional revision on the original price versus quantity. But in reality, there are all kinds of discussions about nowadays the price-based instrument and quantity-based instruments. In a lot of the cases, the distinctions are blurred a little bit. For instance, in the emission trading market, because the prices are so volatile, so governments wanted to put a price ceiling and a price floor, when the market price reach the bound. So if you have a price ceiling, basically means that if the price is too high in the market, actually it's basically turns into a carbon tax. So that is a hybrid system. Okay. And in the emission trading systems, you can also think about ways that there will be similar to the carbon tax. You can also raise the auction revenues. And in the carbon tax system, you can also put a downstream tax at the firm level. Okay. So you can have all kinds of things. And you may even think about a way that you can both have a carbon tax and emission trading. So the distinction basically is not that so obvious. So sometimes it's all really depend on in the practical system and how you actually design the tax policies and emission trading policies. Okay, so now it goes back to the thing is, we know that to abate carbon emissions will take a lot of money. So I wanted to highlight the importance of international climate finance. So let's take a look at, let's just take 1 year annual emission. Let's look at the country contributions. So China, for the last roughly 30 years, from 1990 to 2019. So the magnitude of emissions in 2019 is roughly 3.4 times of 1990. It contributed to 27% of the global emissions. And India, for the same period, according to the United Nations CTAD data, the emission also increased by 2.89%, accounts about 6.6% of global emissions. The sum of the total developing countries counts about 63%. So it is very important for the developing countries to abate emissions. But this is not easy because in the developing countries, and most of these emerging countries, they have to deal with the economic growth and the conflict between the growth versus emission reductions. So it is indeed a lot of the developing countries really need this financial support to shift from the high carbon used country to a low carbon used country. Under the Paris agreements, so if under these Paris agreements 6 years ago, so the whole idea is taking full account of specific needs and special situation of the least developed countries with regard to funding and transfer of technology. So we have already acknowledged and highlight that for developing countries to effectively control the emissions, there are basically two most important issues to address. One is the funding sources, and the other one is technology transfer. So if I cite the G77 officer, Mr. Thacker, so what he talked about is we cannot be talking about ambition on the one hand, and yet we show no ambition on finance. So actually this year in Glasgow, COP26, the climate finance is also the most hot topic here. If you look at the Glasgow Climate Compact, this climate pact, basically out of 8 chapters, 6 chapters include climate finance, especially the chapter 3 is about adaptation finance, and chapter 5 is about finance, technology transfer, and capacity building for mitigation and adaptation. So you can see that all kinds of these issues is talking about how can developed countries help developing countries in terms of international climate finance, and how can we get it? So I think this is very important. We can link this to the policy instrument that we just discussed. Okay, so let's talk about carbon tax. Carbon tax is a very useful tool that if you impose a carbon tax, and then you can basically get the carbon tax revenue. So that revenue, I think, is a very, very promising sources for the international climate finance. The emission trading, if it's not grandfather emission trading, if we have an auction-based emission trading, we can also connect the auction-based revenue and use that to finance. So the public sectors can also, and even the private sectors can allocate it certain amount of the financial resources to the abatement and adaptation activities. So I think overall, from different sources, there's big potential to have a carbon international climate finance. So let's take a look. Under the Paris agreements, the target is we needed to have 100 billion US dollars per year from developed countries. According to the most recent data in 2019, it seems that we might have 79.6 billion US dollars a year for the next few years. We're still not get the 100 billion target, but it seems quite likely that we're going to reach this target. But this might not be enough. Actually, at this year, COP26, there are more and more evidence suggests that to deal with the climate change issues, this we probably need to allocate more resources to help the island countries and developing countries. So the 100 billion US dollars might not be enough, especially since Paris agreements, they are also, for the previous years, there's also this kind of financial gap. So in order to collect enough money from both the public sector and private sector, it is very important that we could adopt useful instruments to get enough revenue and get enough funding sources to facilitate the international climate finance so that we can help the island countries to adapt to these climate adaptations. And also we can allocate this to more low carbon technology, innovation, diffusion, and transfer. Only when all the countries to collectively to go for the same direction, then we will be optimistically that we can reach this 1.5 degree. Okay, so I think I'm all done with the lecture, and I'll save some time for the Q&A session. So if anybody has questions, you can either turn on your microphone or you can type your questions in the chat box, then I can answer that. Okay, so thank you all for listening to my lecture. Thank you. Okay, so I'll wait here for a few minutes and try to collect some questions here.